Students, please ask your friends to join the meeting immediately. Kindly cooperate. Vishnu Raman, Gandhi sir.
Yes, ma'am.
Two charger. Vishnu Raman, Gandhi Selvan.
Ma'am. Yes, ma'am.
Please ask others to join the meeting immediately.
Yes, ma'am. Yes, ma'am.
Pandiselvan. Pandiselvan.
Yes, ma'am.
Only 6 students joined from second year. Please ask others to join immediately. Session
Yes.
is going to start.
Yes, ma'am.
As I instructed you already, all the third year students must attend this event. And I request you all to ask your friends to join the meeting immediately. Start பண்ணலாமா சார்?
ஸ்டார்ட் பண்ணுங்க. ஸ்டார்ட் பண்ணுங்க மேம்.
Yes sir, yes sir. I'll do so. Madhumithaa? Madhumithaa?
Yes, ma'am.
Are you ready, ma? Shall I start?
Yes.
Good evening, everyone. And good evening, everyone. A warm welcome to all of you at the guest lecture on Reconfigurable based control applications in electrical engineering of Department of EEE SRM Valliammai Engineering College. SRM Valliammai Engineering College, a division of SRM Group of Educational Institutions for Privileged Learning, is functioning under the Valliammai Educational Society, which provides quality education in the various fields for more than 3 decades. With the noble vision of educate to excel in social transformation since 9/9/1999. The UGC New Delhi and Anna University Chennai have granted autonomous status approved by AICTE New Delhi and affiliated to Anna University Chennai, Tamil Nadu. The college offering 2 programs, namely Engineering and Technology and Management. In this, 11 undergraduate courses and 8 postgraduate courses are offered by SRM Valliammai Engineering College. The Electrical and Electronics Engineering program is approved by the AICTE and affiliated to Anna University Chennai. The department is ISO 9001:2015 certified. National Board of Accreditation has accredited the BE program for a period of 3 years. The department prides for its 12 state-of-the-art laboratories with modern equipment, and it has AICTE sanctioned 2 model schemes for electrical machines and web-based electronic devices and circuits laboratory. The department also offers postgraduate program in power system engineering since 2010. So taking our evening further, and to begin with the introduction of the speaker, I thank the management for giving this opportunity, and I welcome HOD EEE Dr. K. Ilango and the speaker of the guest lecture today, Ms. Madhumithaa, who is alumnus of our college. She is working as Application Development Associate, Accenture Solutions Pvt Ltd, Bangalore. I welcome all our staffs and students who are all joined for the event. Ms. Madhumithaa Rajaram done the certification courses in Introduction to IT and Cybersecurity, Satellite Photogrammetry, ISRO, Electrical CAD, Ethical Hacking, Hardware Development using Embedded Systems, ARM Cortex M0 plus LPC 812. She has designed and fabricated of mechanical parts with multiple photographs based 3D printing of model photogrammetry based single extrusion fused fabrication 3D printer. She has learned to design password based circuit breaker. She has designed the circuit board for ultrasonic range sensor, and she did project on structural coordination multidimensional objects. She worked on the projects like UK-based finance client project. It is a client project on investments, policies, and insurance, which is having the reputed background of workflow ranging from new money to use money functionalities for a customer. Automation test flow tools like hands-on Selenium, Tosca, EFT, Cucumber. API testing tools hands-on, Ready API, Swagger. Regression, functional and live testing on the CRM tool. I'm very glad to invite Ms. Madhumithaa Rajaram onto this platform so as to get an opportunity for all of us to listen to the speaker. Thank you. Madhumithaa?
I hope I am audible.
Yeah, you're audible.
Yes.
Can you share your PPT?
Yes.
Yes, your PPT is visible.
Okay. Good evening, one and all. This is Madhumithaa, who is an alumni of this college, Valliammai Engineering College. So here I am to present the reconfigurable based control system applications in electrical engineering and its strengths. So I think many of us are studying control systems right now, and I assume everyone is from the engineering background. So let me just introduce to the basic of control system, and then we will move into the reconfigurable structure based on the control system applications. So please let me know if this slide is moving.
Yes, it's much moving.
Okay. So basically, a control system is a network of either any electrical or any electromechanical device which is used to regulate a particular process through control loops. I think many of us would have heard of any device, electrical, say electronics, any device which has an input, which we will give as an input, and basically it will give out an output. That is called a system. In that system, any device is basically measured to give us some output based on the process it follows or the design we are giving it to process some output. So when I say anything about control system, it just means I'm going to design a device. I'm just going to give an input and I'm expecting an output. So in the input that I give is taken as the variable process as to which I'm designing the particular device, and the output will be the set point. So what will, just like any other device, for example, when we talk about electrical, we can say ammeter, voltmeter, everything is desired to give us some output based on the input that we are giving it. So always we standardize the output of any device based on how we are achieving out of any ideal system. For example, if we take any temperature sensor, we will be giving certain input, let us say the room temperature, and we are expecting it, the sensor, to sense it and give us the output as to how the climate changes or the temperature change is. The output that we are expecting out of it is directly related to any ideal system which has been set in the starting of the evolution. So there are two types of control systems. One is open loop control system. The other one is closed loop control system. So let's talk about open loop. Whenever we give an input, there is a controlled circuit, there is a controlled process, and we are expecting a desired output out of it. So without any loops, that is the input of any structure or any device is immaterial of what the input is, the output will be taken. So this is about open loop. Coming to the closed loop structure, whenever there is an input and we get an output, there is something called as error signal that will be created, which is the difference between the output and the input, which will be fed as a feedback to the input again, so that the system becomes a controlled closed loop. Yeah, so the efficient control system that we can see out of these two is always the closed loop, because any feedback signals that we feed in is going to regulate the process, the dynamic process for which the device is set to act for. Okay, coming to the next slide, the basic control applications in the industries. I think many of us would have heard about SCADA and ICS. A SCADA is basically the supervisory control and data acquisition system, which is used in major substations to control all the data related to the substation with respect to the hardware and the software components. So it is basically a latch between both hardware and software, where the whole SCADA system runs in a software unit, whereas the whole software has all the hardware components in it. For example, here in this diagram, you can see there is a circuit breaker, there are switches, there are regulators, and there are measurement devices as well, which gives out reading in and out. So any person who is sitting remotely in a substation or in a remote distanced control room, they can monitor the whole substation results, and they can monitor the whole setup for the substation by sitting just in front of a system, and they can supervise the whole data. So let us assume there is any fault that is happening while the system is running. In that case, the person will be alarmed about the fault, and they will be informed immediately, and they can take action according to the fault that is occurring. Coming to the industrial control system, it is basically the integration of hardware and software devices, but it has all the wire and wireless networks connected together. In the right side, you can see the industrial control system, where people are monitoring a remote access data system, which is having both hardware and software, just like SCADA, but has a different control. And there are, so the basic control loops that are being widely used in the industries are the supervisory control and data acquisition, that is SCADA, in substations, and ICS in whole range of space, aerospace, intelligent technology, remote sensing technology, and everywhere. So coming to the vast system that we have always seen, the distributed control system. Everything that we receive at our home, everything that we receive both industrially and domestically, it is called the distributed control system. Like we have previously discussed, any system which has which has a driven input and there is a desired output out of a process, any dynamic process is called control system. So that control system is channelized into both industrial and distributed. So coming to the distributed control system, we can see it is used in major high voltage AC transmission devices and high voltage devices majorly in the plants such as oil, gas, or any heat production gases. There it is majorly used. So here in this diagram, you can see a basic plant is there, out of which a distributed process area is covered, and each process area is covered by a process unit separately. It can be distributed to a wide range of areas covering a whole system. So this is one of the majorly used and which is the most popular method of control system distribution. So now that we have seen what a control system means and what the basic structure of control loops that are being seen everywhere in the industries, there are some basic components that we have come across through the learning. One is a programmable logic controller, which can be used to control the logic, to control any system logically by using zeros and ones. And the second thing is programmable integral derivative controller, PID we call it. And here you can see there is a set point and there is a process, that is the PID, which has a feedback structure to it. And the sensor, I think many of us would have seen many major sensors such as temperature sensor, ultrasonic sensor, and many more, moisture sensor. I think many of us are used to IoT devices and the new technological aspects of these sensors, right from your malls till your day-to-day life learnings. We can see everything related to the sensor. And coming to the intelligent electronic devices. So the major intelligent electronic devices that you would have come across is microprocessor controllers, which is used basically for IoT devices in small scale and used as motherboards and CPUs in case of large scale, and remote terminal units, which will be used basically for telecommunications, satellite communications, and all those. So these are the basic components that we see or come across in the day-to-day life. Other than this, we have multiple range sensors, and we have some of the mathematical models as well. So having a brief introduction about control system, now we have to know what is control reconfiguration, which is basically the topic that we are going to deal about for the next half. So reconfiguration, the word itself means we are going to configure a change, configure or bring about a change in a particular system which is already processed to a certain dynamic process. So control reconfiguration is nothing but any control reconfiguration is nothing but an electrical network where you can achieve the fault tolerant control. So in this diagram, you can see there is a controller, the input, output, and the feedback. Here in the plant, we can see an FDI, that is fault detection system, is added, where whenever there is a sudden fault or when there is any instability in the system, the fault detector unit can just detect the fault for us, and the fault is then sent to the reconfiguration unit, where it stabilizes both the controller input and the output, acting as a feedback as well as fault detecting equilibrium. So here the major points is that we can achieve this only by using major techniques. And whenever there is a severe fault, such as the actuator or any sensor outages can break out into a, then it can be restructured to prevent the failure of the system, and it can stabilize the system automatically so that the original process of the control system doesn't get interrupted. So if we see as to why we are going for a reconfigured model of control system is because we want to increase the scalability and we want to increase the dependability of any system which has a feedback control, so that it becomes a much more efficient way of controlling a device. So in this system, you can see any controller which has a plant attached to it. It has a fault detection system which will take up the fault. It will give the output of the fault given to the reconfiguration system, which will interpret the input and the output as and when it can equalize or stabilize the whole system. There are many approaches to how the reconfigurations can be approached or attached to the particular control system that we are dealing with. So whenever we are introducing any system into a something existing system, we call it an innovation. So there is certain goal to achieve reconfiguration. The first will always be preventing the plant shutdown. As we have seen that distributed control system is one of the major and which is most viable source of control system in the whole industries. It is always important to check the shutdown of any plant so as to not interrupt the whole flow. So for that, the first goal of reconfiguration is to prevent any plant shutdown and then stabilizing the whole control and to recover the equilibrium. So once and when any instability is there in the system, the detector should automatically detect the output and should take in a charge to send it to the reconfiguration system, where it will set a priority to set up the state as an equal to the controller input, that is the process variable, so that the output doesn't get interrupted to the distributed contribution of areas. The third point will be the equilibrium recovery and output trajectory recovery, and then to stabilize the following state which has been set initially and what will be expecting out of it as a result, and the transient time response recovery. Though there is a system where we can approach the reconfiguration of a control system, it is still a very, very crucial process, a very inconvenient process for anybody to adapt it into the system, because the complexity is very high, and though we have many goals in recovering it or reconfiguring a system, only a couple of cases are practically possible. So coming to the first approach and the only approach that is being set as of now is the fault hiding approach, where here in the diagram you can see a fault plant is there and a nominal controller with an input is there. So there is a reconfiguration block that is set in between those two so as to stabilize the nominal controller whenever any fault occurs. So here you can see we have talked about 5 to 6 goals, but always in a practical situation only at least 2 of them are implementable. Here you can see equilibrium recovery goal is achieved and the trajectory recovery goal is achieved as per the sciences that is going through. So whenever there is a reconfiguration block that is set up in between a faulty plant and a nominal controller, the configuration uses the results of the fault diagnosis component, that is the FDI we call it, to restructure the control loop and to adopt the controller to the faulty plant. And then it sets the multiple signals that is manipulated out of the reconfiguration block, and it will measure it according to the controller, which is relative to the nominal controller. It will ideally set the set point so as to reach the equilibrium position, and the loop cannot be further restructured. So there are certain, like we know, only fault hiding approach is recently being established and is being implemented in major plants. There are certain other approaches which can be implemented in future, like linear model following, optimization of the based control schemes, and neutral networking. So there is another concept called fault accommodation. So always when in the control system, only the outer, that is the external approach of the structure can be reconfigured or it can be controlled. But in case of fault accommodation, the reconfiguration can be achieved internally also, which is being more efficient throughout the years. So fault accommodation is in contrast to the control reconfiguration. As discussed previously, there are certain mathematical approaches also to achieve reconfiguration using the adaptive control, intelligent control, model predictive control, and linear matrix inequality. These are just few of the controls that I'm naming now, but there are lots and lots of other mathematical approaches that is being incorporated into control system theory. The most fascinating thing about any control system is it finds an application in all the real-time processes that we see through. For example, we take aerospace sector, anti-skid system. We can see any car which has all sensors, motors, and a cruise control and anti-skid control for the tires. Each and every component that we see in any electromechanical or any electrical parts is related to something of a control system which is being controlled basically for to achieve a certain desired output. Let us say we have a car, we are designing a car or we are manufacturing a car. We have to set up different parts in different market units and production units. We are going to set up a standard point where which it will meet the original point by giving an ideal input. So certain system will be designed as such, it has the system. So whenever I create a system, it has to further achieve whatever is desired out of the control system that is being used. For example, here you can see fire alarm system. So the basic is it will take the input of any temperature related things or any pressure or moisture related things from the room temperature. It will take that as the input signal. It will interpret all the signals and it will give out an output. So whenever there is a fault or any detected result, it will alarm the system, it will alarm the whole network, and it will give an output which is stabilizing the whole system, and it is also preventing us to work on the major faults that can be occurring in the future. So the real-time application not only are the ones that I have put here, there are many other applications that are in control systems. For example, in ISRO, that is the Indian Space Research Organization, they use a lot of intelligent control systems and distributed control systems to launch a PSLV or GSLV or any other small missions. It not only has application in the wide industries, but it also has the space in small industries. Let us say ICs, manufacturing, latching, in all the other small components till the micro to macro products, it is completely relevant. So let's talk the basics of how the control system has evolved over time. Initially, James Clerk Maxwell in 1868 started researching about control systems, and his discovery was based on one of the centrifugal governor systems. So it basically a centrifugal governor system, it basically will regulate the velocity of a windmill. So it all started from there. James Maxwell started observing the behavior of the centrifugal governor, and he found out that there was an issue with how the self oscillation has been occurring. So we can see when anything is self oscillating, let us assume, there will be always a lag in the stability of the system. So that is when the control system, the birth of control theory started, and the centrifugal governor system was 1 minute.
Madhumithaa,
Ma'am,
do you need any help?
system is not okay. There is some issue with the system. Ma'am, for now, I'm just closing this slideshow.
Yes, please.
Yeah. So continuing with how the history started. So we were talking about the centrifugal governor, which was used to regulate the velocity of windmills. So the issue that the person was facing was out of the self oscillation that he found out, which had been giving a lag in the stability of the system that is being unstable, and the process of the output is also being deferred out of what is expected. So the second invention of the existing control system theory was the crewed flight, where the concept of bang bang principle started coming into play. It was for the automatic flight control of an aircraft, which in today's which in today's days is really very important and one of the promising sectors in the aircraft field. And the second one is the fire control system and the guidance system of electronics, where the fire control system was established with many major control system techniques and sensors to detect and to process the faults efficiently so that it is reached to the customer frequently and in a more interactive and interruptive way. So any sensor or any control system comes into invention whenever there is a need or whenever there is a instability in the system or whenever there is a reproach to some enhancing of a system. And all the inventions that we see today in the day-to-day life, right from your escalators, elevators, and till the IoT devices at home, Alexa, light control systems, music control systems, everything will come into existence only from how the stability of a system will work. Stability and reconfiguration does not only mean that we have to enhance the system scalability. One. Yeah. So the control system reconfiguration or any control system technique is not just related to the enhancement or scalability of any system's performance. It is also based on how we reduce any achievable output or any achievable result without interacting or interrupting with any other systems which is integrated to it. It also makes us deal with the component related processes and not only the integrated process. I think there is some issue with the presentation. So this is all about control systems and their applications. So reconfiguration of any control system is based on the fault tolerant system. So how much ever efficient a circuit or a product is made to be fault tolerant is how efficient and long lasting the particular product or the device is going to be used in the real time. So majorly in bigger systems of HVAC, like distribution systems of transformers or any other heat related or gas related devices, needs these kind of reconfigurable control system networks in order to achieve a special fault tolerant technique, so that um, it enhances the stability and it also keeps the whole process without any interruptions, without any further disruptions in distributing it to a larger areas. And economically also it will be very achievable, so that it doesn't go under high maintenance. So thank you for this opportunity. I would like to thank Ms. Vanilla, um, Mr. Venkatesh and Dr. Elango, and the whole department of Triple E for giving me this opportunity. Thank you.
Thank you, Madhumithaa. I thank Ms. Madhumithaa for giving lecture on the topic on reconfigurable based control application in electrical engineering of Department of EEE SRM Valliammai Engineering College. We hope that our students enriched with reconfigurable techniques in control system engineering. I thank Ms. Madhumithaa Rajaram once again for spending your valuable time with us and sharing ideas about control system engineering. I thank our head of the department, Dr. K. Lango, faculties, and the students who joined the event. I thank you all.
Ma'am, voice கேட்கலாம்.
Yes. So I thank Ms. Madhumithaa Rajaram for giving lecture on the topic on reconfigurable based control applications in electrical engineering of Department of EEE SRM Valliammai Engineering College. We hope that our students enriched with reconfigurable techniques in control system engineering. I thank Ms. Madhumithaa Rajaram once again for spending your valuable time with us and sharing ideas about control system engineering. I thank our head of the department, Dr. K. Lango, faculties, and students who joined the event. I thank you all. Dear students, if you have any questions, queries regarding this emerging technique on reconfigurable techniques in control system engineering, you can clarify your doubts with Madhumithaa Rajaram. Students, now the space is yours, so you can utilize this time properly.
Question எதுனா க்ளோஸ் பண்ணுங்க.
Okay, sir. Madhumithaa?
Yes,
Madhumithaa, can you please turn on your video? So photo session, if possible.
yes, ma'am.
Thank you so much.
Thank you.
Thank you. Thank you, Madhumithaa. Thank you for joining with us. Thank you so much. I thank you all. I thank you all the participants who joined for the event. Thank you.
Thank you, ma'am.